Okay, since I do not know how long the hurricane will last, or actually how long we will be out of school due to the weather, let me at least give you your next lab.
I think the practical thing would be trying to get school back again by Wednesday next week. You released everybody.
You know, I can't predict the weather, but even more, I can't predict the administration.
Yes.
I can predict the weather better, actually. So, I'm going to, and I'm not blaming the administration. They have a lot of things going on. I'm not trying to put them down. I'm just saying it's hard for me to predict them. So I'm going to give you Lab 2. So if you're stuck somewhere, you can at least work on Lab 2. You can at least think about Lab 2 if you don't have power and write it out what you think it should be doing, because some of this will be a little tricky, especially Part 3. All right, threads and synchronization. It's going to look very familiar because this first paragraph is saying this before, basically tell you virtualize Linux. It may work under Bash. Have many of y'all been doing this Bash under Windows? Has it been working so far? Awesome. Tell me if you ever run into problems, because I'm interested. Nah, I love them. They did that. All right, so first off, we're going to explore. The purpose of this lab is explore a program to compute the number of primes from 2 to n. You may look up different ways to do this for a single-threaded factorization, but for this exercise, I really recommend the simple test, namely this piece of code right here. Will tell you if the number is prime or not. Notice I'm passing in a log, so these numbers I'm passing could be huge. And the code's already wrong because this I should be a long. Whew, that was bad. I'll be fixing that. Part 1. Create a program where it creates n additional threads. Instead of processes like last time, this time you're creating threads. N is passed in as a parameter. Same thing as your process, except it says I'm thread in. I gave you the way it's done down here, gc-lp thread. One thing I forgot to mention, to get the sqrt function, you need to include math.h, and you need to include the math library with -lm. Down here is -lp thread. Make sure you add -lm as well.
Will you put that in?
I will, remind me right after this to put that in, because it's not hard. Part 2, copy it over. It's going to take n and m. N's number of threads. M is arranged from 2 to m to test for primes. M shall be a long. So in C, make sure you do A to L and not A to I. Let me make sure you understand what I'm saying. Man, A to L. Convert. ASCII to long returns long. A to I, ASCII to integer. So make sure you call A to L. Yeah, long. Your program shall print out the number of primes from n to n, utilizing the n threads. So you need to somehow figure out how you're going to utilize each of those n threads. Ensure that each thread is consuming some amount of work. I am not asking for perfect load balancing on part 2, so I recommend you just divide it out equal ranges and then dole them out to each thread and let them compute it from there. Okay? Hopefully that's at least intuitive, that if you doled out equal ranges, it's not equal work, because higher numbers are going to take longer to determine their prime than lower numbers. Because if you look at this loop, it's going from 3 to the square root of whatever that number is. Part 3, again, once you're done with part 2, copy it over to lab 3, we're going to extend it. You take 3 parameters, n's number of threads, m is the range, and the size is the maximal range that each thread may work on. I'll explain that in one moment. We're going to extend your previous lab to now do something called thread pools, essentially, where you're going to have a thread pool, and then you're going to have an amount of work, and then those pools are going to your threads are going to pull from the pool and do work. It's kind of producer-consumer in this situation. So create your n threads. Divide out the ranges into chunks of sizes not greater than size. So you got to figure out the size. You figure out the range. Size may be, for example, 1,000. And if I gave you 1,000,000, then you should have about 1,000 different ranges or chunks in your pool that a thread can pull from. So you got to think about this because it's going to require some extra coding to figure out how to get this working. Each thread shall, while more ranges exist and are not done, get the range and compute the numbers in that range, and then when no more ranges exist, report the sum to the parent thread, and then go ahead and exit. Gather all the sums and print the result. Hmm?
Sums.
Because the sums,
Summing.
yeah, because you're summing the number of primes in the range.
Oh. Do we have to list them though? Or
No,
just- oh, okay.
I just want the final number of primes within the range. Don't have to list them. Don't care about that. So part 3 is going to be a little on the difficult side, I understand. I'll tell you right now, if you don't understand this,
Gotcha.
as long as you implement thread pulling, I'm going to be okay. All right? If you don't, if you need some extra help with this to understand it, please ask questions. Do you have, John?
No, a thread pool, we're implementing a thread pool.
Yeah, so a
Right.
thread pull is,
So we create our chunks of maybe 1,000.
your thread pool is a size in, has in threads in it. You create your chunks, maybe you have a 1,000, maybe in is 10 and your chunks, your ranges are 1,000. So those 10 threads are going to just be constantly pulling from the pool, working on it. When they're done, go back to the pool, grab some more, work on it. When they're done, go back to the pool, grab it. And then if their pool is empty or there's nothing else.
Pool of threads, are we talking about a pool
So you
of
got
threads?
in, you have your pool of in threads.
Okay, gotcha.
Hold on. And then you have your pool of work or your ranges.
Which would be the numbers.
Right. So I don't know why I put a line there, but I sure did. So your threads, 1, 2, ... in. Your ranges, 0 to 1,000, 1,000 to 2. Well, let me do this exactly. Although it started 2. Just trying to be precise.
So the ranges are already divided up into like
You
little
have to do
chunks.
that, yeah. Yeah, you divide out into equal chunks
Based on size.
based on size.
Why did we start at 2?
From 2 to m.
Yep. You saw that there, like,
So hopefully there's more ranges than threads, and a thread is going to pull from the range pool, but you have a pool of threads that are pulling from the ranges. Just implement thread pulling somehow. This is how I just recommend doing it. Any questions?
So do we come up with a number of range pools?
The number of these,
Yeah.
that will be determined because you have 2 to m is your full range, your size is the maximum range in here.
Oh, okay. Cool.
So if size, I'm saying in this example, size equals 1,000. So each one's 1,000 in size.
well, we're going to get the number of threads, we're going to get the threads, when we get the, let's say the range is, we went 2 to a million or whatever, 2 to whatever your range, oh no, the range.
Yeah, 2 to a billion, sure.
Sorry.
2 to a billion,
A million.
2 to a billion, and your size is 1,000, so you'll have 1,000,000 ranges.
So
Hopefully you'll be changing. Obviously when you run the program, I'm going to make something respectable between the two.
Yeah.
So that would just be, I'm not going to make it so you have like a million ranges would probably be the most I'd ever throw. Yeah, that's probably the most I'd ever do.
So we can just be like, blah, do this one, blah, do this one, blah, do this one.
So the point of this, the reason why we're doing the thread pool is this is all the work. He's going to be pulling, let's just say for some reason this guy is got the super hard chunk of work. Since he's taking forever, someone else can pick up the slack and start working on the rest of his work as well. That's the point of thread pulling.
Wait, on the rest of his?
On the rest of the work. No, I'm sorry, not the rest of his range, but on more work while he's still trying to do his range.
So,
The point I'm trying to avoid is don't just divide it out and shove it to each one. You need to be doling it out.
so it's like, but for the ones they actually pick from the range, can't just be like, blah, get the first one, blah, get the next one.
In the
So
range,
the
yes.
first one
Okay, I
be-
see what you're asking, yeah.
Like, there's no point to like go out of that order with doing them or anything.
There's no point per se, no.
Cool.
So yeah, you could just have your other thread. Yeah, you don't have to actually store all these ranges. You could just have your parent thread be holding on to what the next range would be.
Well, so the first part's not too difficult, because we take it through the parameters, we got it there, we just, once we've got our algorithm set up for that, that's fine. But it's the second part, where your program shall divide out the range of chunks of size going on, that's fine. It's that part, each thread shall, while more ranges exist, we are not done.
And we're not done. AKA,
Yeah,
more
okay.
ranges exist. I'm being redundant.
Well, that also kind of specifies don't stop as soon as someone's consumed every range.
Right. Everyone must be
They're all-
complete.
Yeah.
All ranges must be complete.
That's yeah. Then you're good to go. So you may be waiting on another thread at the very end. That's okay. Although, yeah, we'll just leave it like that.
That's not that bad.
Hey, it's not. It seems difficult, but if you sit down and think about how to simplify it, it's not bad. All right. I think I issued 2 weeks. 2 weeks. Hopefully, we'll be out of done with the weather by then. Any other questions? Good. That's all for today. Enjoy your
Vacation.
vacation.